Good day. I am Ruben James Rosal from the Organic Synthesis and Supramolecular Chemistry Laboratory of the Institute of Chemistry, University of the Philippines, Diliman. I will be presenting our research on the structural modification of quercetin and evaluation of their interaction with SARS-CoV-2 ACE2 by docking studies. Coronavirus disease 2019, or most commonly known as COVID-19, is a viral disease caused by severe acute respiratory syndrome coronavirus 2, or SARS-CoV-2. This virus caused an outbreak of a mild to severe respiratory tract disease that spread rapidly worldwide and was declared a pandemic in March of 2020. Viral entry is initiated by the interaction of the receptor binding domain of SARS-CoV-2 spike S protein and human angiotensin converting enzyme 2, ACE2. This interaction is a pivotal determinant for SARS-CoV-2 infection, making it a possible target for small molecule-based drugs that may exhibit some protection against SARS-CoV-2 infection. Natural products, especially flavonoids, exhibit diverse bioactive properties, and they have been investigated as SARS-CoV-2 ACE2 inhibitors. Of particular interest is quercetin, a flavonoid that is found in higher amounts in some berries and herbs and has the potential to disrupt the SARS-CoV-2 ACE2 interaction. In this study, the derivatives were designed based on Swiss ADME predictions and literature procedures. The purity of the derivatives were evaluated using high-performance liquid chromatography, while the structure identification of the derivatives were performed using nuclear magnetic resonance spectroscopy, liquid chromatography mass spectrometry, and Fourier-transform infrared spectroscopy. Docking studies were then employed to investigate the interaction of the synthesized and proposed derivatives to the SARS-CoV-2 ACE2 complex. Receptor frames that were used for the molecular docking experiment were obtained from 2 microsecond coarse-grained molecular dynamic simulation of spike HACE2 PDB ID 6VW1 6VSB. The docking grid box was centered on phenylalanine 486 residue of S1' receptor binding motif with a box dimension of 30 by 30 by 30 angstrom. O-trialkyl quercetin analogs were synthesized in moderate yields. The structures were confirmed through NMR, LCMS, and FTIR. The synthesized compounds were relatively more nonpolar to the parent compound. All except compound 5 adhere to the Lipinski's rule of 5 for drug likeness, making them probable drug candidates. Based on the docking results, 3 derivatives have significantly increased binding affinities compared to the parent compound. From the protein-ligand interaction profiling, it was observed that there is significant improvement in the binding energy upon substituting some of the hydroxyl groups of quercetin with aromatic groups. The effect of the extensive pi-pi stacking overcomes the contribution of the loss of the hydrogen bonding interaction, which was not observed in the allopathic derivatives. This study has shown the structural modification of quercetin resulted in a significant improvement in the binding affinity in comparison with the parent molecule due to the enhanced interaction at the SARS-CoV-2 ACE2 interface. This shows that the synthesized and proposed derivatives may have the potential to inhibit the viral entry process. Further studies on the selective alkylation of the derivative should be done to increase the yield of the desired product. It is recommended to perform 3D QSAR analysis to optimize the structure of the quercetin analogs, which can give a more improved binding energy. Future works on the synthesized derivatives will be done to evaluate their in vitro SARS-CoV-2 ACE2 inhibition and toxicity. The following articles were used as reference for this study. We would like to thank the DOST PCHRD as our funding agency and the DOST ASTI COARE and UPD College of Science CSRC for providing us computational resources. And again, this is the structural modification of quercetin and evaluation of their interaction with SARS-CoV-2 ACE2 by docking studies.